from elementary school as alligators, right? They eat the bigger, right? So there's greater than, or there's less than, or there's greater than or equal to, and there's less than or equal to. So an inequality is the symbol greater than, less than, greater than or equal to, less than or equal to. So when we're working with inequalities, seventh graders, this might be new to you, so you're going to have this out with you. If it is a greater than or a less than, when you graph it, the graph is an open dot. So if you had something that looked like x is greater than 8, if you had x is greater than 8, if I have a number line and I do 6, 7, 8, 9, 10, right? If I have x is greater than 8, my value that I'm comparing x to is the value of 8. So I'm going to draw an open dot at 8 because I'm drawing a fence around 8. It can't be 8, so I don't fill it in. So I draw an open circle at 8. Now here's my question. X is greater than 8. So which way would I go to find values that make this true? What are answers? What is greater than 8? X is greater than 8. What are some values for x that would make this true? What are some values, Ethan? Excuse me. That is a perfect answer. Where would that fit? To the left or to the right? To the right. I'm going to shade up, right? Because x is greater than 8 is this way. Anything that is greater than 8 is a possible solution. How many answers are there to this problem? Infinite answers. Because 8.1, 8.2, 8.01, right? Anything that is greater than 8 is a solution to this problem. If it's a greater than or equal to, right? If it's got that equal to bar, or it's a less than or equal to bar, right? If it has that equal part, the graph is a closed dot. So if I had -4 is greater than or equal to m, -4 is greater or equal to m, I'm going to draw a number line. And -6, -5, -4, -3. Now, some people don't like it if the variable is not written first. Looking at this is confusing. They don't know what to do. So if you want to write your variable first, that's fine, but you have to remember, the inequality is opening towards the -4, so when I rewrite it variable first, my inequality has to open towards the -4. You can't just flip-flop these and not flip-flop your inequality. If your original inequality, the alligator, right, is eating the -4, when you rewrite it, it still has to open towards the -4. So I'm going to draw a circle at -4 because that's my value that I'm working with, and I'm going to color it in because I could have -4 as an answer. I'm shading in possible answers. And is m greater? Is it going to go up to the right? Or is m less than? Is it going to go down to the left? Is m greater or is m less than? M's less. So I'm going to go down. So we're going to apply this to this idea to linear equations, y equals mx plus b. So we're not just going to stick to just one variable, right? We're going to put it in a linear equation, y equals mx plus b. So the first thing you need to do today, maybe, is solve the inequality for y. It needs to be y equals mx plus b, or since it's not an equal sign, y is greater than, less than, greater than or equal to, less than or equal to mx plus b. Instead of an equal sign, there will be an inequality. There's a special rule when you're solving inequalities that you might have to do, not always, but you might. If the coefficient of y is negative, flip the inequality. This is the thing that people forget all the time. So once your inequality is in y equals mx plus b, you're going to graph the y-intercept and the slope. Right, whatever the plus or minus number is, you go up or down to that number, put a dot. Then from that dot, you count the slope, rise over run. Remember if it's negative or positive. But here's the difference. Because after you put your y-intercept and you counted your slope as many times as you could, what did you do when you did linear equations? You put your y-intercept, then you counted your slope, and you had all those dots. Then what did you do? You connected the dots, correct? We're not going to necessarily do that this time. If it is greater than or less than, it's a dashed or dotted line. It's open. It has holes in it. Just like up here, if it was greater than or equal to, you drew an open dot. Down here, if it's greater than or equal to, you draw an open line. It's got dots in it. It's not connected. If it's greater than or equal to or less than or equal to, it's a solid or connected line. It's a closed line. So maybe you'll have to solve the inequality for y, maybe not, maybe it's already done for you. Remember, if the coefficient of y is negative, you're going to have to flip the inequality. You're going to graph the y-intercept and the slope, and then you're going to decide, am I going to connect the dots? Does it have an equal sign? Do I connect them? Or am I going to dot the line? Not connect the dots, make it dashed, make it not solid. And then we're going to shade. starting at the Y-intercept, if y is greater, or y is greater than or equal to, there you go. Starting at the Y-intercept, so you're going to find the Y-intercept. If y is greater, or if y is greater than or equal to, now I want you to think about it. On a coordinate plane, which way does y get bigger? Going up. Shade above. Because the y-axis is vertical. And that's kind of the hard thing to transfer this from, because a number line by itself is horizontal, but we're now working horizontally and vertically, right? We're working on a coordinate plane instead of just a number line. Because y is greater going up. And if y is less than, or y is less than or equal to, which way does y get smaller? Down. Three graphs along the bottom. Right along the bottom, because we're going to put problems up above it. I think I gave out too many graphs in the beginning. Put your graph in here. Extra sleep. Just get brief.
Do we just glue at the bottom?
Yep, glue at the very bottom. Here's trash. So to graph this, we use our skills that we learned at the beginning, right? When we did linear equations. This starts at 4. Positive 4. My slope should be a fraction, correct? What is my slope in this linear inequality? 3 over 1, meaning I go up 3 into the right 1 because they're both positive. I can't go up 3 into the right 1. So what do I need to do? Down 3 and negative 1, correct? 2 negatives make a positive. I'm going to do it again. 1, 2, 3, backward 1. 1, 2, 3, backward 1. I fit as many slopes as I can. Now I need to decide, is this going to be connected or is this going to be dotted? So you look up here. Is it dotted or connected, dashed or solid? It does not have an equal line. Here's how I remember it, you guys. If it has a line underneath it, you make a solid line. This does not have a line underneath it, so I'm going to dash.
How do you remember that? No, how would she, how does she do that?
Because I've been in 8th grade math for 14 years. All right, so I did step 1. I didn't need to solve the inequality, so I was good. Step 2, I graphed. I did that. Step 3, starting at the Y-intercept, so I'm going to put my pen on the Y-intercept right there. Is Y greater? So do I shade up? Or is Y less than? Y is less than, so I'm going to shade below. So I shade everything below the line. Any answer, any ordered pair in that shaded area is a solution, is an answer to the problem. Any answer, any ordered pair, 4, 0 is an answer, makes this a true statement. 0, -6 makes this a true statement. If it's on the line, it does not work because it does not have an equal to. It cannot be on the line. It must be underneath the line. Any of those ordered pairs work. All right, let's try this one. Y is greater than or equal to -8/5 x minus 4. Shh, gentlemen. Y is greater than or equal to -8/5 x minus 4. Y is greater than or equal to -8/5 x minus 4. All right, so I'm going to graph it because I don't need to do number 1, solve the inequality for y. It's already y is by itself. So I'm just going to graph it, -4, and my slope is -8/5, meaning down 8 to the right 5. But I can't do down 8 to the right 5, so what do I do instead? Up 8 and to the left 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. I can only fit 2 dots on this graph. Sometimes that happens. Now I need to decide, is this connected or is this dotted? Why is it connected?
Because there's a line under it.
There's a line underneath it. It's equal to. So the answer could be equal to this line. So I'm going to connect the dots. Then I'm going to start at the Y-intercept, so right here. And I ask, do I shade above or below? Is Y greater or is Y less than? Y is greater, and Y is greater going up or down? Up. So I shade everything above. So any answer, any ordered pair in that shaded area or on the line, because it's a solid line, would work. All right, I'm going to write a little bit up here because we're going to have to do some math. All right. 3x minus 2y is greater than or equal to 6. 3x minus 2y is greater than or equal to 6. 3x minus 2y is greater than or equal to 6. Jacob, write the problem down. Step number 1, solve the inequality for y. Do we have to do that? Yes. So I'm going to move 3x to the other side, and if I move something across the equal sign, or the inequality, it changes to negative, correct? So -2y is greater than or equal to -3x minus 6. Do you agree? Is y alone now? No, what's with the y? -2, correct? So I need to divide by -2. So y, and ladies and gentlemen, the coefficient of y was negative, right? -2. So instead of it being y is greater, I'm going to have to flip it to y is less than. Do you know what -3x divided by -2 is? Oh my gosh, you guys forgot everything over spring break or over Thanksgiving break. 2 negatives make a positive. Do you know what 3 divided by 2 is? No. It's a decimal. We don't want that. So 3 over 2x. That's if your coefficient is negative. If your coefficient is positive, if that was positive 2y, you wouldn't flip it. But since it's a negative value, we have to flip-flop it. What's negative 6 divided by negative 2? Positive 3. 2 negatives make a positive.
Plus 3.
Now let's graph it.
Yeah, why is it negative 6?
Because, oh, just kidding. We'll make it a negative 6. Sorry. I made it a negative 6 in my imagination. Yes, sir. Yep. All right. Positive 3. Now what?
3 over 2.
1, 2, 3 over 1, 2.
And then you have to go down.
Then I have to do 1, 2, 3, backwards 1, 2. 1, 2, 3, backwards 1, 2. 1, 2, 3, backwards 1, 2. Lots of dots, right? Do I connect them or do I dot them? Because there's an equal to bar. All right, then step 3, starting at the y-intercept, so right there. Is y greater? Do I shade above? Or is y less than? Do I shade below?
What?
Y is less than. It's not eating the y, right? I shade below. And this one we had to flip, right? Originally we would have shaded up, but since my coefficient of y was negative, I had to flip-flop it.